Since rational functions are one of the more complex functions, we utilize these 5 main components to ultimately help us graph and understand the components of a rational function. So our first main component is going to be looking at our domain. And to find that, that'll be when all our x values for which f of x does not equal 0. And to find that, we're just going to set our denominator equal to 0. Our second component would be looking at our excluded values or discontinuities. And the first one we're going to want to take a look at are wholes, because those are removable. So to find wholes, we're going to factor the numerator and the denominator. And if there's the same factor in both the numerator and the denominator, that's going to be our whole. So we'll set that factor equal to 0 and solve. The solution is going to be our x value of the whole. Then we'll just take that x value and plug it back into the equation to have our coordinate of the whole. Now, if we don't have any wholes within our rational function, we'll have vertical asymptotes. So again, to find these vertical asymptotes, similarly to finding the domain of the function, we'll set the denominator equal to 0. And the values that make the denominator equal to 0 are not going to be a part of the domain. So our third component is going to be looking at our end behavior of the rational function. So the first one we're going to want to take a look at is our horizontal asymptotes. So to find those, we compare the degrees of the numerator and the denominator. But in this case, we can see that when our degree of the numerator is larger than the degree of the denominator, that's going to leave us with an oblique, also known as a slant asymptote. So this occurs when the degree of the numerator, again, is greater than the denominator. And to find this slant asymptote, we're going to use polynomial division, which I have another video on. So our fourth component is going to be looking at the intercepts. So to find these x-intercepts, we can set the numerator equal to 0, and to find the y-intercepts, we can set all the x values equal to 0 and then solve for y. So our fifth and last component is just going to be testing different intervals. So we'll test different points within different sections of the graph, and this will ultimately lead us with a finished graph of a rational function.